This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 136. Happy World Meteorological Day, everybody. We have a great presentation for you. The title is Using Satellite Imagery to Assist with Mesoanalysis. Our presenter is John Howell, Science and Operations Officer from the Mobile, Alabama Weather Forecast Office. Our facilitator after the presentation will be Bill Line, physical scientist with the Regional and Mesoscale Meteorology Branch, RAM-B of NESDIS STAR. Just a few reminders before we get started. As you just heard, this session is being recorded, so your colleagues can catch this later. It'll be posted on YouTube. There will be an opportunity for Q&A after the presentation. We particularly encourage attendees from our forecast offices and regional headquarters to ask questions. Please post your question in the chat and we will field them in the order they are asked. If you have a longer question that you'd like to talk to, please just note accordingly. Also, if you have signed in with an office account, please note your full name when asking a question in the chat. That way we can follow up if necessary. Also, just a reminder that some of the email communication related to the Satellite Book Club and Tower S team may be in your spam folder, unfortunately, so please keep an eye there for any future updates. We're always looking for future presenters for the Satellite Book Club, so if you have a presentation, maybe you gave it at the most recent annual American Meteorological Society meeting, please repurpose it in the form of a Satellite Book Club seminar. And if you're looking for training materials that may be unavailable, Brian Mata at the Office of the Chief Learning Officer can help with that. I'd like to thank the Tower S team, particularly Kashad Bowman and Lee Byerly, the Office of the Chief Learning Officer, and the GOZAR and JPSS program for their support of the Satellite Book Club. Of course, thank you so much to our facilitator today and presenter and all of you for being with us. Without further ado, let me introduce Jonathan Howell, who is the Science and Operations Officer at the National Weather Service Office in Mobile, Alabama. His interests strongly reside in severe weather mesoanalysis and warning operations, forecaster training, and tropical weather. John, we're glad to have you at the Satellite Book Club today.
Hey, good morning or afternoon, wherever you're at. I really appreciate you all having me, and I just want to thank again Lee and Kashad, folks over at Tower S, for allowing me to present today. I'm very grateful to them for the opportunity and all the assistance they've provided here over the last several months. So thanks to those guys. I guess we can go ahead and get started here, or we ready to roll?
Yep, good to go.
Okay, great. Again, hello everyone. I wanted to present today using satellite imagery to assist with mesoanalysis, and you know, that's mesoanalysis near and dear to my heart. Here, spending most of my career in the Southeast U.S. Obviously, we have a lot of severe weather occurrences in this region, and there really isn't, you know, other than the warning operator in operations, I think, you know, there really isn't much more important position than the mesoanalyst, because that individual is tasked with keeping everybody informed of environmental conditions, changes in the atmosphere, and both at the, you know, in the mesoscale and local scale, storm scale, that could change storm modes and really have an influence on things. And you know, as an event's unfolding, they play a pivotal role in keeping our radar operators informed, as well as passing key messaging to our core partners, so that they can make good decisions in a high stress situation. So let's jump into this. What I've got today is just a little bit about why I think it's important, and then also I'm sharing a case that we had in our area that had some really interesting applications for mesoanalysis, and why it's so important to incorporate satellite imagery into that review. So next slide. You know, we can think of this satellite can be applied at all scales of the forecast funnel, all the way from the synoptic scale, where we're kind of looking at the overall pattern and, you know, taking a look at, you know, what the large scale synoptic forcing mechanisms would be for a severe convective event. And actually this can apply in any type of event. Obviously the focus here is on severe weather, but it's not limited to just severe weather. It's really can be applied to any type of high impact weather situation. So I like to get a start, when I'm in the process of performing a mesoanalysis and I just get onto the desk, I want to take a look at the large scale pattern and see where, any kind of large scale features synoptically that would help to force ascent and result in convective development. So we're a good tool to start in that process. I think the real benefit of satellite imagery, especially nowadays, is that it provides the best temporal and spatial resolution of really any tools that we have. With the rapid scan and high resolution data that, especially in the mesoscale sectors where we're getting 1 minute imagery, really we don't get much better data sets that's continually updating and providing such a nice, constantly updating tool to use when we're performing mesoanalysis. I like to use water vapor imagery to kind of see the synoptic scale and kind of compare it with other observational data sets, really to get a good understanding of what kind of environment we're dealing with, and again, identifying those large scale forcing mechanisms. Next slide. So, after we take a look at the overall synoptic pattern, we come down the funnel and kind of start digging into the mesoscale details. Obviously, during the daylight hours, we have more tools to use in our satellite tool bag that help us to identify boundaries, understand the stability of the atmosphere based on cloud types. We can also get clues of the environment locally based on, how convective cloud types are evolving with time. If we have orphaned anvils, it may have an environment that's not quite there ready yet to support deep convection, but it may be on its way. At night, we're a little bit more limited, but we can still utilize the infrared products. I like to use the total precipitable water products to see, determine atmospheric moisture, that can support deep convection. So there's really just a multitude of options available to the forecaster for digging in and really getting a true understanding of what's going on in the local mesoscale environment. Next slide. And then we can even apply our knowledge of satellite down at the storm scale. Obviously, if you're out in the Great Plains, this is probably going to be, a more beneficial tool as compared to us folks over here in the Southeast, where you get more discrete supercell type setups more often. Obviously, here in the Southeast, it's quite moist, and we get generally we get storms. We get a lot of storms that develop. So sometimes these storm scale clues get obscured. But I really encourage, like, if you're on the mesoscale desk, to be looking for these features when they appear. Even here in the Southeast, there's opportunities at times, depending on the setup, to see some of these features. And I think there's some opportunities here as well for trying to find new satellite schemes or techniques in which we could better resolve these storm scale features even when they get obscured. So I think there's some research to be done there. I encourage all of you that are out there that dig into this data and have a strong understanding of that to really, if you have some ideas, kind of investigate that, because there's much to be done still. And we can combine this satellite imagery with our other data sources with our real-time VAD to build photographs on the fly, Also, observation, all sorts of observational data to create the true picture of what's going on. And then we can use that again to inform our radar operators of changing conditions, how things are evolving both on the mesoscale and storm scale that may actually change storm modes and threats. And then we can message that out to our core partners, really where DSS, where the rubber hits the road with that. Next slide. Yeah, and here's just to reiterate, where we can play a strong role in the messaging in the near term, based on these environmental or these observational clues that we're getting from our different data sources. And again, satellite is one of the most important because, again, we're constantly getting updated information that we can see how the atmosphere is evolving almost in real time. Next slide. So I want to jump into a case here that occurred here across the portions of the deep south, north central Gulf Coast, and that evolved into our forecast area on April 17th of last year. I think it really shows the importance of where we can apply satellite techniques and see how things are evolving. And going through this, you'll see we don't ever look. I won't ever look at any model data. Really, we should be jumping into the observational data first, and then letting the short-term modeling support what we're seeing in the observational data set, or we can disprove it. Like, are the cams out to lunch? Because what we're observing isn't really panning out in the modeling that's available. So there's real opportunities when we dig into it to get an accurate forecast in the near term. Next slide. So we started out this day with some uncertainty in the forecast. We had a slight risk in place, across much of the lower Mississippi Valley that extended eastward into the Mobile County warning area. There was, the potential for some supercells to develop and then evolve into more of a QLCS type setup. But there, as you'll see when we get a little bit deeper into the data, where the uncertainties lie and what could play a role in potentially changing what eventually evolves. Next slide. So as you can see here with the early morning water vapor imagery from 12 to 14Z, we had a lead shortwave that was ejecting moving across the lower Mississippi Valley with a stronger shortwave back over the southern plains. You can see here already the challenges that we may face and why the uncertainty was great this day, because we didn't really know how the afternoon setup would be dictated by the morning convection that was developing with the lead shortwave. How far was the warm sector going to be suppressed? Would this morning activity, would it totally disrupt our ability for severe convection later in the day with the second stronger shortwave feature? Those are the questions that we had to answer early in the morning. So next slide. Okay, so here you can see we're jumping ahead in time. What had happened, and due to the interest of time, the morning convection spread out across east central Mississippi and then eventually into southern and southwest Alabama and then into the Florida Panhandle. You can see some of the convective elements off to the east there over the Panhandle associated with that lead wave. But looking at this imagery, there's a lot going on, right? We have numerous boundaries that have laid out across our area, and different air masses in place based on what has already evolved during the morning hours. If you can advance here, we'll show the boundaries that were in place. We had the primary synoptic cold front, well, actually at this point it kind of becomes stationary, that extended across north central, or from central Arkansas across north central Mississippi down into portions of west central Alabama and then eventually into southeast Alabama. And again, convection even as late as 1930 Zulu was still occurring, across south central into southeast Alabama and into the Florida Panhandle. But back to the west, you can see that the air mass had stabilized quite a bit, right, behind the morning convection, and there was the synoptic warm front was laid out further to the south, and it was kind of influenced and driven by the convective outflow from the morning activity, and that boundary became a real good focus for where we wanted to take a look for where we may have secondary development with the main shortwave approaching from the west. Further to the south, you can actually see a marine warm frontal boundary that's separated somewhat unstable and a destabilizing atmosphere from that of the pure marine, richly moist, deeply moist, strongly unstable air mass further to the south across southern Louisiana there. And we can see all this kind of set up. If you notice, we had residual billow clouds to the north of the convective outflow, where the air mass had been stabilized, but in the process, we were actually eroding the billows and actually destabilizing the atmosphere as the boundary was slowly starting to retreat back to the north. The marine warm front was also gradually lifting off to the north with time. Next slide. Oh, and then you can see there where we had the agitated Q and eroding billows within the air mass between the two surface boundaries. And you can advance through, and we should be now on the visible IR sandwich imagery from 18 to 20 Zulu. And you can see in this imagery that lead shortwave was still driving convection off to east. We had the boundary that extended back up, from near the Mobile area back up to the northwest. And then we had the convection back to the west, so it was starting to develop gradually as the large-scale ascent and forcing associated with the deeper wave over the southern plains was ejecting to the east. But in between, you can see how the billow clouds were still in place there, but they were gradually eroding to the north. And also, if you notice, we had some attempts at convective development along that boundary during the early to mid-afternoon, but we had some challenges. We were kind of in between systems. We knew that was the focus for the afternoon and evening development, but the timing was still a bit in question. We knew it was going to take some time until the larger scale ascent moved in and helped to support deep convection. But the atmosphere was continuing to be oh, I'm sorry, I lost my train of thought there. The atmosphere was still being preconditioned along the boundary. As you can see, we had some orphanambles, we had attempts at deep convective development, but it was kind of falling off with time. So if we advance to the next slide, just wanted to show some of the lightning data that we were looking at. Again, really showing that the convective development during this time period was really struggling along the boundary. Next slide. Okay, so as we jump forward to the 20 to 0Z time frame, you can really see the much stronger mid-level wave pushing in and enhancing large-scale ascent across the lower Mississippi Valley. And this is really the time frame when everything started to evolve. Everything started to erupt along the boundary. We had the forcing coming in that really supported the convective development, and it's interesting to see how everything evolves with time. Okay, next slide. So we looking at the photograph. We built this using Autumn Sky, and we typically do that during our You know, the mesoanalyst in operations typically is looking at this information because I think it really provides some good information that supports, how the environment is changing, kind of gives us some clues as to storm type to expect. And we can see here, this was using the VAD profile or VAD winds from Slidell at late afternoon, 2342. As you can see, we had, an environment supportive of supercell structures at the time, the 0 to 3 kilometer bulk shear values approaching 40 knots, and 0 to 6 kilometer bulk shear was approaching 64 knots. And as you can see, when we plotted our storm motion onto the hodograph, any storms that were able to get deep enough and utilize the hodograph were capable of having right turners dominate, or right turners dominate. Even those right turners will get off the boundary. That's actually the boundary that was in place, as you can see by the gray line, that was stretched across the area. So they were right turning into the warm sector. So they were able to get off the boundary overall, and they were moving right of the right movers when they became deep enough. So, we had some tornado threat and some potential for discrete supercells along the boundary out ahead of the approaching stronger cold front back to the west. So eventually, once the cold front caught up, that was going to change our storm mode. But initially, we were expecting, when we saw this data, some potential for discrete supercells that would right turn off the boundary and have a tornado potential and also damaging wind potential. Now, overall, we can see storm relative inflow was somewhat marginal. It was around 25 knots, 26 knots there, 0 to 1 kilometer storm relative inflow. So at first, with those weaker low-level storm relative inflow winds, our updrafts were somewhat narrower, and I think that was kind of indicative of the struggling period that, that period in between the lead shortwave and the secondary shortwave. Our updrafts were still a bit narrow. There was some dry air aloft, so we were dealing with some dry air entrainment in the storms that weren't allowing the convection to fully evolve and become deep with wide updrafts. But this kind of environment changed with the approach of the secondary wave, with low-level wind fields strengthening, so we were able to sustain larger updrafts and take advantage of the full hodograph. So storm relative velocity was improving, and as you can see from the hodograph, we had fairly good majority to 0 to 1 kilometer flow. It was curved enough, and we had good component of streamwise vorticity being ingested into the updraft. So again, tornado threat was there, but mainly a damaging wind early on. As we can see, moving forward and looking at our IR Viz sandwich, we can see that the storms really erupted. If you notice, there were some convective towers that went up early. And I didn't tell you to advance the slide, so we're on the Viz IR sandwich 20 to 0Z. You can see the convective towers with the supercells that evolved just ahead of the main line of convection back to the west. And you can see that in the Viz IR satellite imagery with cold cloud tops out ahead, but it quickly evolved into more of a QLCS with time. So the original forecast was fairly good. As you can see, you can really pick out the lightning with those leach supercells that were more discrete, and then the just a lot of lightning activity with the actual QLCS that developed. Taking a look at radar, you can see there's the supercells that actually evolved out ahead during the basically the 22 to 0Z time frame. These cells actually went on to produce some isolated tornadoes, but mainly a damaging wind threat. It was interesting when we jumped further ahead. Next slide. When we jump further ahead and look at the modified photograph from Slidell at 1 Zulu, we can see now that we have the cold front the cold front was advancing at a rapid pace, moving about 40 knots. It was interesting, as you can see here, obviously the lead supercells were undercut by the advancing QLCS line, but we were able to orient our 0 to 3 kilometer storm shear vector. Became much more orthogonal to the actual initiating line, and we kind of transitioned, even with that QLCS, to a pattern that was favorable for mesovortices within the QLCS line. And the funny thing was, when this occurred, and I'll show you the radar here, where it was catching up, where we had reorientations, and this is where I think the Mesoanalysis 2 can play a good role. You know, we have reorientations of the convective line that supported a more perpendicular orientation of the 0 to 3 kilometer shear vector to that initiating boundary, and we ended up getting more tornadoes with the QLCS in this setup than we did with the lead shortwaves out ahead. And these are the kind of things that, you know, as things are evolving, we're looking at our observational data and why it's really important that the Mesoanalysis is utilizing all these observational tools to you know, make these kind of analyses and inform the radar operators, and then also to let our partners know that, hey, look, you know, storm mode is evolving, so the threat is evolving. The hazards that are going to come from it are evolving. So it's really important to you know, include all of this into your analysis. And there's a next slide. As you can see here, here's kind of the storm reports from that day. Again, mainly focus on that boundary that was in place, that old convective outflow boundary that laid out from the initial morning storms, and that was the focus. So you can see where you can really take advantage of the partner messaging by utilizing what you are observing on your satellite imagery and other observational data sets that support that. But you really, again, get a good temporal look and almost real-time evolution on where the boundary is positioning, and you can see the movement, and that's really useful in your messaging to stay on top of that and tell your partners about how things were going to evolve, timing of convective initiation, you know, and how the threat may start as one thing but evolve to a different scenario. Next slide. So that kind of wraps it up. So in summary, again, I really think, you know, satellite is a very strong tool to use in the mesoanalysis process. And, you know, we should really be using these observation tools to really support what we see in our model guidance when we're serving that mesoanalysis position. It's such a great tool, especially now that we have the highly temporal resolution of the satellite imagery. And it really helps with the overall DSS message that we're providing. So just, you know, I would just continue to, you know, encourage everyone to really utilize all of these tools to their advantage when dealing with these high impact type situations. Next slide. And that wraps it up. So hope you enjoyed it. You know, I'll be interested to, you know, hear your thoughts or take your questions, and you know, hopefully we can get a good discussion going here. Thanks again.
All right, John, thanks a lot for that presentation. That was really great. I really like that you were able to walk through a case for us. So I'd like to encourage all of our attendees to stay on for the discussion that'll start in about a minute. We'd especially like to hear any relevant comments and questions from our National Weather Service field offices and regional headquarters partners. Really, any relevant comments or questions would be great to hear. If you're asking a question in the chat, please make sure to include your full name in the question if it's not already showing. Also, Tristan just entered a link to a feedback survey. We'd like to encourage everyone to fill that out as well. So before we start the discussion, I just want to mention that in a week from today, on Thursday, March 30th at noon Eastern, John Forsyth, a senior research associate at CIRA, will present on multi-satellite water vapor and derived products for forecasters. I definitely look forward to this presentation. I think it's a very timely topic given the weather the West Coast has been dealing with over the last few months. Finally, I also want to encourage attendees to contact the Tower S team, specifically Lee Byerly and Kashad Bowman, for questions about the Satellite Book Club or for configuration of satellite products. You can see their contact information on the screen there. All right, last reminder to please enter your questions in the chat or comments, or if you'd like to speak verbally, please indicate that in the chat and we could hear from you, and we certainly like to hear from as many folks as possible, especially Weather Service folks. So please, any comments or questions, get them in there. All right, so first question, John, for you. Could you discuss a little bit about some of the forecast challenges or observational gaps that forecasters still face during the mesoanalysis process that current observational data sets fail to capture?
Yeah, that's a good question. Yeah, I think the challenges, at least in my mind, especially in moist environments such as and unstable environments where we such as here in the southeast portions of the country, and I kind of talked about it in the presentation, where we get a lot of convective development. It's hard to see what's going on down at the storm scale, and sometimes even the mesoscale. Sometimes cloud cover will obscure the ability to see these important specific boundaries, and sometimes we have to, that is one of the limitations to some of the satellite imagery and its use. Obviously we want to turn to other data sources, observational data, but sometimes the temporal resolution of that can be a challenge. So again, and that's when I kind of talked about in the beginning, if we can find some techniques and ways to resolve these features, even when we have some obscuration of them in the current setting, that would be fantastic. So obviously, doing some brainstorming here and working with some of our forecasters to see if we can find some solutions to overcome those challenges. But it's really kind of an open question right now, and I would encourage everyone out there to really dig into those questions and see if we can find some good solutions to that.
Thanks, John. Folks, still plenty of time to get your questions and comments in the chat. So next question, John, I thought your point discussing messaging, the importance of including satellite data or information that you're getting from satellite data in your messaging. Do you or our forecasters explicitly including satellite images in messaging and public posts to help get your messages across?
Yeah, we have before. We've used some of our social media outlets to graphically show, like situations like in this event where we had boundaries that were in place and kind of talked about the importance of that boundary and how, that would, likely be a focus for convective development through the afternoon. And then we kind of tie the other environmental or environmental information into that, to really message storm threats. as you could see in this case, obviously there were a lot of clues. You could see boundaries, you could see stability of the atmosphere. You could really analyze where your, timing of large scale forcing. So really there was a lot that you could glean from the satellite information that was really informing, the evolution of how everything was going to, develop, and when the timing of the greatest threats would occur. And we do attempt, at least locally, to include that into our messaging, and definitely harness this in the overall process, because I think anytime we can provide that kind of specificity to our messaging, to help partners with those decisions that they have to make on their end, really is at the heart of what we're trying to do here with our DSS services. So no, that was a good question. Thank you.
Great. John, is your office, or do you leverage NewCap soundings to assess the stability in the pre-convective environment?
Some of our forecasters are utilizing that information. We haven't, there's been more of a focus on looking at the, just the characteristics of cloud types and things to assess the environment. Obviously here in Mobile too, we're not an upper air station. So, that limits some of our ability to get, information about the atmosphere from soundings. But again, I think there's plenty of clues, in the overall data, especially satellite and even radar, that can give us clues about the stability of the atmosphere and really point us in the right direction. We've really harnessed that, and it's been beneficial to our severe weather operations.
All right. Yeah, John, when analyzing the larger or synoptic scale environment, are you leveraging all 3 water vapor channels on GOES?
Absolutely. Yeah, because of limitations in time for the presentation, I just stuck with the mid-level imagery. But yes, we're looking at all features, because waves, that are not as deep, mid-level waves that are not as deep may show up, at lower levels as compared to, maybe our deeper waves that we can see on mid and upper level water vapor imagery. So yes, we do harness all 3, everything that's available to us. Thank you.
Awesome. And I know you mentioned this. Maybe you could go to the GLM slide and briefly summarize how GLM was used again in this case.
Yep. Let me get to that here. If you guys can pull it up on your end. I think like in the 18 to 20 Zulu imagery, it really, we were seeing those convective towers attempting to develop, right? And we would get some lightning activity, it would show up on GLM, but we never got any real good, strong lightning jumps or pulses, and it really gave us a clue that the atmosphere was just not quite there to support or sustain deep convection. Obviously, we were able to utilize that data though to understand that we could see orphaned anvils, we could see the lightning data that was pulsing up and down, but it gave us a clue that there was going to be a delay in sustaining deep convection for some time. And I think that's the kind of information that you want to include in your partner messaging, right? Because they may see some of this lightning starting up and think it'll just, storms will just erupt. But we can utilize what we're observing in both lightning, satellite imagery, and our understanding of large scale forcing mechanisms to really kind of lay out the timing, for our partners, and let them know, hey, this is going to be a focus, but that focus is going to be delayed for a couple hours, until we get better forcing in. The atmosphere is attempting to become more favorable for storm development in these areas, but again, not quite there yet based on the clues that we're seeing. So I think that's where we really can, where there's really a benefit to digging in and observing what's going on. And I know that kind of jumps a little bit off of lightning, but it's part of the toolkit, right? That gives us clues about what's actually going on that we can utilize in that messaging. So good question, thank you.
All right. Maybe one more question, unless there are any more coming in the chat. John, is the goal to have, is the goal to have all forecasters in a weather forecast office equally capable of performing this type of mesoanalysis? And whatever the goal is, do you see any training gaps in reaching the goal of having all forecasters sufficient at doing this type of mesoanalysis?
Yeah, that's a great question. Everybody, obviously we're all at different, we all have different strengths and different skill sets, right? But I think, if we can start with our folks that really have a strong interest in that, and we've seen this in our office too, where we start really hitting the training hard and with the people that are really interested, and then we take that set of forecasters and really encourage them to get others that may be a little bit nervous about this process or have some reservations. You have those people that have already bought in and are highly skilled to really start the mentorship process, because the SUE can't do it all, right? I mean, it's obviously, obviously we would love to have the time to train everyone and get everybody fully proficient in mesoanalysis and the processes and the messaging and how to tie it all together. But it's an evolving process, right? And we all have to work together as a team, to build our skill sets through the office. So ideally, would I love to have every forecaster in my office, top mesoanalysts? Of course I would. Is that a reality? Maybe not quite, maybe not yet, right? But if folks that are really excited about this and really good at doing this, not only continue to develop their understanding and their skills, but also mentor the folks that kind of maybe, not so sure of it. I think that's really helpful. And also doing it in a safe environment at first, allowing people to make mistakes. It's okay. When we do a lot of hands-on training in our office, and, I'll get in and do some one-on-ones, and, and the first thing I say, this is a safe environment. You're going to make some mistakes, and that's okay. Because the only way you're going to learn is if you make those mistakes and then learn from it. So we're in the process of building, our skill sets in this area. Is everyone 100%? We're not quite there yet. Is that realistic? We have new people coming in. We have more experienced people going out. So we're always in a transition. But the ultimate goal, the end goal, is to make as many people as possible, as many forecasters as possible, as skilled as they can be, and apply this to their forecast process. I hope that's a good answer. I'd like to hear if somebody else has a different approach out there for that.
All right, John, thanks a lot, John. That was a great presentation and great discussion. Please reach out to John if you have any more questions or comments on this topic. Unfortunately, we're out of time, and I will pass it on to Jordan now.
All right. Well, thank you so much for that presentation, John, and thanks, Bill, for facilitating our Q&A. Just a reminder to everybody, the Satellite Book Club continues every Thursday. Next week is no exception. March 30th at 12 noon Eastern Time, we're going to have John Forsyth, Senior Research Associate at CIRA, is going to talk to us about multi-satellite water vapor and derived products for forecasters. In the meantime, if you have any questions for the Tower S team, please reach out to them at the emails on the screen. With that, I'll once again wish everybody a happy World Meteorological Day. Hope everybody's spring is off to a good start and hope you'll be back next week. Once again, thanks for attending and thanks to our presenter. Bye, everybody.
Hey, thanks again.